Welcome back to Paper Pills, the podcast where we break down complex research papers and make them digestible for everyone. I'm Abby.
And I'm Carl. Today we're diving into the fascinating world of sleep and how it changes with the seasons.
Ever notice how your sleep feels different in the winter compared to the summer? We're going to explore that, based on a research paper titled Seasonality of Human Sleep.
It's more than just wanting to hibernate when it's cold outside. There's actual science behind it. Let's get started.
So, why is it important to understand how our sleep changes with the seasons?
Well, our bodies are intricately connected to the natural world, and light plays a huge role in regulating our sleep-wake cycle. Think about it. It's harder to fall asleep when it's light outside, and easier when it's dark.
Exactly. And that's because light affects the production of melatonin, a hormone that helps regulate our sleep. During the longer days of summer, we're exposed to more light, which suppresses melatonin production and can make it harder to fall asleep.
And in the winter, the opposite happens. Shorter days mean more darkness, leading to increased melatonin production and potentially longer sleep.
There's been some previous research looking at seasonal variations in sleep. Some studies suggest that people sleep longer in the winter, while others have found an increase in sleep disorders like obstructive sleep apnea during colder months.
This particular study wanted to take a closer look at objective sleep measures, things like total sleep time, REM sleep, and slow-wave sleep, to see how they vary throughout the year.
And they focused on patients in a sleep clinic, which gave them a unique opportunity to collect detailed sleep data in a controlled environment. So, how did the researchers actually go about studying this?
They collected data from a sleep clinic in Berlin, Germany, throughout the entire year of 2019. The clinic specializes in neuropsychiatric sleep disorders.
It sounds like a good place to get in-depth data.
They initially had 292 patients participate in a standard 3-night polysomnography, or PSG. This means they were hooked up to machines that monitored their brain waves, eye movements, muscle activity, and other physiological signals while they slept.
3 nights in a sleep lab. That must have been quite the experience for the participants.
Indeed. But multiple nights are common for sleep studies, as the first night can be affected by simply being in a new environment, and sometimes the third night is used to evaluate any new treatments being used. The focus of this research was on night 2, their typical night's sleep without alarm clocks, to get the best idea of their usual sleep patterns.
Makes sense. So everyone just slept whenever they wanted?
Well, mostly. They were encouraged to keep to their normal sleep schedule. Lights out was determined by each patient, but they were also discouraged from setting wake-up times. They wanted to capture the most natural sleep patterns possible.
Did they analyze all participants?
No, they had to exclude some participants due to certain medications known to affect sleep, technical issues, or unusual sleep patterns that might skew the results. They ended up with 188 participants, 98 women, and 90 men, ranging in age from 17 to 81. All right, let's focus on what they discovered. The study looked at several sleep parameters, but the most interesting findings revolved around REM sleep and slow-wave sleep.
For our listeners who might not be familiar, REM sleep is the stage of sleep associated with dreaming, and slow-wave sleep is the deepest, most restorative stage.
Exactly. They found that REM sleep duration was significantly longer during the winter months and shorter in the spring and summer. We're talking about a difference of about 30 minutes on average.
That's quite a substantial difference. So we're getting more dream time during the darker, colder months. What about slow-wave sleep?
Slow-wave sleep was surprisingly stable throughout most of the year, averaging about 70 minutes per night. However, they noticed a significant dip, about 50 minutes shorter, during the autumn months.
Interesting. So while REM sleep seems to follow the changing seasons quite closely, slow-wave sleep gets disrupted specifically in autumn. Any theories on why that might be?
The study speculates that it could be related to shifts in circadian rhythms and melatonin secretion. Melatonin, the hormone that regulates sleep, is affected by light exposure, and the shorter days of autumn might be playing a role. They also looked at REM latency.
Which is?
REM latency is the time it takes to reach the first REM sleep stage after falling asleep. The study found that REM latency was shorter in autumn and winter compared to spring, about a 25-minute difference.
So we're entering the dream world faster during those seasons. Overall, it seems like there's a pretty clear pattern emerging here, with our sleep architecture shifting in response to the changing seasons. So, Carl, what do these findings mean for our everyday lives? Should we be changing our sleep schedules with the seasons?
That's a great question, Abby. The study suggests that it might be beneficial to adjust our sleep habits, particularly for those struggling with insomnia. Given that people tend to need more sleep in the winter, Shifting our bedtimes earlier during the darker months could improve sleep quality.
It's almost like our bodies are naturally programmed to hibernate a bit during the winter, isn't it?
Yep, and the findings about REM sleep are fascinating. While more research is needed, understanding these seasonal variations could lead to new strategies for improving sleep, particularly for people who experience seasonal mood changes or difficulties with sleep during certain times of the year.
The study also mentioned the impact of daylight saving time, suggesting that the shift to standard time in winter might actually be aligning with our natural sleep patterns by allowing for more light exposure in the morning.
That's an interesting point. It suggests that perhaps we should be paying more attention to our body's natural rhythms and aligning our schedules accordingly. Of course, this study focused on patients in a sleep clinic, so we have to be cautious about generalizing these findings to the broader population.
Yeah, the study participants all had pre-existing sleep disorders, and many were taking medications that could affect sleep. It's also important to note that the study was conducted in an urban environment with limited natural light exposure. Further research in a healthy population and under different light conditions would be valuable to confirm these findings.
Despite these limits, I think this research gives us some pretty interesting early signs of how our sleep changes during the year. It opens up some cool paths for future studies, especially in figuring out what's driving these changes and how we can use this info to help people sleep better.
Well, Carl, that was fascinating deep dive into the seasonality of sleep. Thanks for shedding light on this interesting research.
My pleasure, Abby. It's always interesting to explore how our biology interacts with the natural world.
Absolutely. So for our listeners, the key takeaways here are that our sleep patterns, particularly REM sleep and slow wave sleep, can vary significantly throughout the year.
And while more research is needed, these findings suggest that adjusting our sleep schedules to align with the seasons could be beneficial, especially for those struggling with sleep disorders like insomnia.
Precisely. So, as we head into different seasons, it might be worth paying attention to your sleep patterns and considering adjusting your bedtime to better align with your body's natural rhythms. We also want to hear your experience and struggles with sleep. So leave a comment, and as always, be sure to like and subscribe to our socials at Paper Pills.
Thanks for joining us, and yes, suggest us any topic you want to cover. By the way, today's paper is in the description. We'll see you next time with another cool research.
Sweet dreams!